I think it's me. Yeah. Hello everyone, and hello Ingrid. Before I start, I need to explain something now. I'm in a real face-to-face technical training in a laboratory, so I think it's aligned because now my participants is on the break. I get break. If they come here, 6% engineers, it's gonna be hybrid learning at the same time, face-to-face and online. And I'm gonna explain same thing, both of you and my participants. It's related to pneumatics. Before I start, I need to try something else because I need to use second camera. I'm gonna check that one. All right. At the same time, you need to show me on my second camera. Yes. Can you see the second one? Not on the center of your screen, on the left side or top of the screen. Okay. Okay. Now I'm gonna. Yeah, on the left hand side. Now, okay. Now I think you can see the full screen on the center of your screen, and other two cameras on the top or on the left, I don't know. But you need to see both two cameras and my presentation. Is it correct for your side? Okay. Yeah, I have another camera, and both of cameras are active. So, okay, this training related to pneumatics and electro-pneumatics for technicians and engineers in electricity, electronics, mechatronics, mechanics on the field, on the factories. So this small sessions, I'm gonna explain the relationship between among the force, pressure, and area and the pneumatic drives. After this session, you will be able to interpret the relationships. So it's not gonna be. I'm not gonna use some Web 2.0 tools because this is a hands-on training. So I'm gonna try to explain something between these relationships and online, and if I can prove these relationships, I'm going to show some experiment. On my right hand side there's a experiment tool. So why can we use pneumatics? Because I know you are all of them are engineers, technicians from different factories all around the world. I know we use hydraulics, pneumatics and electricity on the field for doing something. For example, you can see here as a cheese production process, not this process, at the end of the process you can see a cylinder. A cylinder, when you push a button, a cylinder press cheese and compress it, and after that when you push another button, cylinder retracts. First, cylinder advanced and move forward, and press the cheese. After that, when you push another button, cylinder turn back and move backward, and the pressure is turned the other side. So this kind of process, when you try to do something in this kind of process, you need to use some drives, some actuators, some components like this. This is a double acting cylinder. On the right side you can see the symbol of the cylinder. It means there are two lines out of the symbol on the right hand side. This means when you apply and pressured air on the left side, the cylinder piston move forward. This is advanced. And when you apply the pressure air, for example, 6 bar or 66 megapascal, when you apply on the right side, cylinder piston move backwards. This is retraction. On the center of your screen, you can see the real structure of a cylinder. Inside the cylinder. Inside the cylinder, you can see the light blue channels. This is a pressure line. When you use this pressure line, this cylinder turns back. It's gonna be easy for you when I explain on the screen. Yeah, it's really easy. It's not complicated. So, okay, I'm gonna try. Sorry. Can you hear me? Because another microphone is open, I think now. Okay. Can you hear me full screen? Now. My camera. Can you see my camera full screen? As a full screen. Okay. This is a double acting cylinder. When you use pressured air here, 6 bar, it is gonna be move forward. This is advanced. When you use pressured air here, this is move backwards. This is retraction. Okay, it works like this. It works like this. It's really easy. But the important point here, yes. This is the question. I need to use some tools for pull or big blue button pulls, but actually I don't need time for my real students, so I'm asking you for oral way. When we use at the same time, same pressure in the cylinder, both sides at the same time, for example 6 bar, how can the cylinder cylinder piston behave? There are 3 options: move forward, move backward, or remain stable. What do you think? Now, I can't use pull or other things because of my students waiting for me, but I can hear you oral way. What do you think? Remain stable. Okay, thank you, Osman Bey. It depends what I'm expecting. Some different approach. Ingrid, what do you think? Backward. All right. Okay. Anybody? Anybody else? Now we can try. What's going on? We can try, and I need to show you. Okay. Now I think. Okay. You need the experimental area now. Can you see it clearly? This area. Can you see? Okay, this is the pressure line. It's not important, this is not important, but you can see just this double acting cylinder. Normally, Mr. Osman said it can be stable. There is a logic. Okay, I understand. Now I'm going to show you the 6 bar pressure air. This board of pressure air is the same. When I open it, you can see the pressure air. And you can hear. When I use one of these, you can see. When I apply this here and open it, okay, this is advanced and I can't control it. I can't control it. It's 6 bar. And when I close it and use like this, okay, backward, then I can't control this. But when you apply at the same time 6 bar, both sides, you said move backwards, and Mr. Osman said stable, stay stable. Let's look what's going on, and then open the valve. Yeah, it moves forward slowly. Can you see? Did you see it? Yes, and I can control it manually, interestingly. It's really hard. This is pneumatic. When I use hydraulic systems, this is 300 bars, and you can control 2,000 kilograms, and it's not possible to move with your hands, but when you apply at the same time both pressure, this cylinder and both sides, you can control it, and it can move forward. Why? Why it's going to happen? This is the formula. Yes, this is the formula. That's the reason. Okay. Pressure equal to force divided by area, and force equal to pressure multiplied to area. Inside the cylinder there's a piston, and in both sides piston surface area different. Same pressure, say, as you can see, same pressure but different surface area. When inside there is an area, bigger area, it means bigger force. Force is bigger than F1 is bigger than F2, so that's the reason this is move forward, and you can control it by your hands because of the differentiation of the force is not really big enough, and you can control this by your hands. So I can turn it in my presentation. Yeah, I know. Time's up. It's gonna finish in 30 seconds. Yes, that's the relationship, pressure, force, and surface area. For the next session, you can find detailed videos related to this subject on my YouTube channel. There are lots of videos about pneumatics, hydraulics, and this kind of things. Thank you for your patience, and I have lots of things here. Tablets, my second computer, and if I have time, I can write something not on the board. Tablet, second PC, and smartboard, interactive smartboard. When I write here, if my students here, when I explain something on the board, at the same time you can see here synchronously. So in this kind of hands-on training, I think it's not bad for 6 or 10 minutes. Okay, that's all for now. Thank you very much. Is there any question? Yeah. Okay. You're welcome. Of course, you can feel free for every kind of feedback. Yeah, it's a good opportunity for me because I'm real. Yes, I'm doing this kind of things as a real job. Yeah, your feedback is precious, really. Yeah, I see. Yeah, correct. But actually, okay. You can ask. No, I'm in now I'm in an industrial academy for Festo Corporation. You know Festo? As a German company, yeah. I'm in a Festo Corporation. There is an industrial academy, and sometimes some companies, some factories needs training, technical training, engineers, technicians, and most of them like face-to-face in this academy, and some of them want it in the factories, and I go to factory and give them face-to-face. But for example, in Turkey, there's a huge company produce glass, lots of glasses. They wanted to train us to train all their technical stuff, and it took 3 months for all of them online. And interestingly, I gave this kind of training from 8 a.m. in the morning to 5 p.m. afternoon, and for all the week for one group. So it's not easy to explain you because you don't have background. I'm in 6 minutes. So when I have time and when I have a target population who have background, this can be useful, and I can show much more explanation. So you can that's the background of this training. But firstly, I prefer face-to-face. Second, hybrid is okay. At the same time, we can record it. But third, you can say interaction videos. If the companies use a learning management system, I can prepare interactive videos. But almost all of the companies want to use Zoom or Teams, so it's not easy to use this kind of thing. So I produce my own videos on my YouTube channel, and when something's slight and lost in the training, I can say that you can see my YouTube channel on the playlist. All the trainings available here. That's my behavior in my technical trainings. Yeah, it's quite different. Yeah. Thank you for your feedback. Okay. No, that was a pleasure for me. This training for the experience in this process, and for the network for all of my colleagues here from different countries. I hear and I learn different things, this different perspective in the process. I think this is the most important point for me, because I do something in training, and when I discuss in this modules, some people say it's quite different from me, and I can catch something and I can use in my trainings. I think it's available for all of us. That's the good point. And second one is you divide this training modules. It's really useful. Dividing is useful, and thanks for your efforts, for Gerard and you. Thank you very much.